Who came here for the first time? Who came to this place for the first time? Okay. Do you know what actually we are going to do today? Yes? No? What is the name of this club which you attended now?
IT Conference Club.
IT Conference Club. Who knows what is the club about? What is the intention of this club? What are we going to do today?
About IT.
About IT. So we are going to discuss IT, or we are going to sing a song about IT. What are we going to do? Who knows?
We can do
Discuss about IT and English.
We're going to listen to a discuss presentation, yes?
We're also going to ask questions.
Artificial intelligence.
Talk and make friends.
Yeah.
Cybersecurity.
So, it's an English-speaking club for those who wants to increase your capacity, speaking capacity, want to understand a little bit about the technology, and mostly to discuss technology in English. It's place, a gathering meeting points for those who want to improve English speaking capacity. So today, first of all, let me pass best wishes from Vyacheslav Sergeyevich, who knows him. Actually, he is missing you so much, and he told me to attend this special event and pass you best wishes from him. And also, I would like to tell you a small story before we start, before the presentation begins. How English capacity, how your English can actually save people's life. I remember myself, maybe 3 years ago, not 3 years ago, 5 years ago, I was moving, I was catching a train, and maybe at 5 p.m. I was asked. Beside me was one guy who was from Canada. This guy has no idea how to communicate in Russian and Ukrainian, and he had some problems with his. He had a huge headache actually, and he asked local stewards in the train to help him, to give him some pills or something, or give some medical treatment. And he was trying to explain this steward what his problem was, and nobody understood him, and no any helps, no any treatment could be put because nobody understood what this guy is asking for. And my modest capacity to speak in English in those times allowed me to understand what his problem was. And actually I was trying to help him, and we managed to help him. He actually had very big problems with his head, and actually train was stopped in the nearest train station, and he was removed from the train and put in the hospital. It may be, and after this station, he wrote me some email. It was 2 months plus after this event. He wrote me email and sent me for this small assistance. That's why actually English could save people's life. But here was a particular case. We are not going to save your life. We are going to help you with your future, because you know current situation is the following: without English language, you will have no prospect in your promotion in the career, in your IT career. So I'm happy a little bit we have so crowded room in this today, and let me pass words Victoria. Victoria is now is co-organizer of this event. He organized and trying to find out people who are brave enough to speak in front of the auditorium. How many presentations are you going today to have to listen today?
Okay, so first of all, I want to greet you all here, because I'm really happy to see so many people right now, and I'm really happy that you are all really interested in learning, in opening and bringing up your skills, and I really thank you. I really appreciate that. And today we're going to hear 3 presentations. Currently we have 2 speakers present, but we hope that our last speaker will come a little bit later. So first we want to start with neural networks, then we'll pass to anonymity and security on the net, and if our last speaker comes, then we'll come to the Wi-Fi security, and this will be the last presentation for today.
So it means if you will continue, to attend this club, definitely in future you'll have such good pronunciation like Victoria has. So I highly encourage you to join this club and make presentation public in the future because it's very profitable for you. Okay? So it's your turn, Victoria. Please.
Yes.
Hello.
Yes. So to begin with, I want to remind you that don't be afraid to speak. If you have questions, don't be shy to write them down if you're going to remember them. It's not scary at all. You have to ask questions. The more questions you ask, the more you speak. The more you speak, the more actually practice you have. So that's the basic idea. You're not here just to listen to interesting and not so interesting topics for you, but also to practice your own skills. So don't be shy, and even if you think that your English is bad, even if you think that the question is stupid, it's not. You have to practice. So just do your best, don't be afraid, and we're going to start with our first speaker, Losha.
Before we start, sorry for this, I would like you to pass the best wishes to Vyacheslav Sergeyevich. Now you're going to make some photo. You do like this, okay? No. All you, please put your hands up and do like this. Smile to Vyacheslav Sergeyevich. Okay, great. Thanks. Yeah, well done.
Let me to help you.
My name is Alexey Bonder, and I'm going to tell you about artificial neural networks and deep learning. Imagine that you have a set of million pictures and you need to tag them, whether it is it's a dot or it is not. How would you do that? Your brain has no trouble recognizing the dots, for instance, even though the specific values of each pixel is completely different from one image to the next. But how can our brain do it so effortless? To solve this issue, we can use neural networks. Artificial neural networks are based on the work of biological neural networks. This is simplified diagram of biological neuron. It has a dendrite. It is part that receives information in form of electrical pulses, then pass it to soma. This part converts this information and activates a neuron. Then through the axon, it goes to next neurons. Our brains has hundreds of billions of these. Artificial neurons are based on biological neuron. It also has inputs, as part that converts information and activates a neuron, and output. Every connection has its own parameter called weight. Weight shows strength of particular connection. Inputs are multiplied by weights and goes to transfer function. Transfer function sums them up and adds a bias in the end. Then the result is transferred to activation function. Concept of activation function. Bias is used to shift the curve of activation function up or down. There are a lot of kinds of activation function. The most simple and commonly used are step function, sigmoid function, and hyperbolic tangent function. Step function and sigmoid function maps the result into a desired range, into a range between 0 and 1. And hyperbolic function maps it into a range between -1 and 1. The structure of neural network is like any kind of networks. It is an interconnected web of nodes and edges that join them together. It has an input layer, output layer, and all layers between them are called hidden layers. If the neural network has more than one hidden layer, it is called deep neural network. So how does it learn? Learning is the most genuine part of deep learning. We can see the process of learning as iterating process of going and return. Going is called forward propagation and return is called back propagation of information. For propagation, we take our data and pass into an input layer. After input layer, it is passed through the whole network until it reaches output layer. Then we get the result from the output layer and compare to the prediction that we had before starting training. We calculate the loss function that will help us to train our network. It's loss function. It's the difference between our prediction and our result. Then we pass our loss function or an error backwards to each neuron in our neural network. When each neuron gets the error, we want to minimize our error. The closest it to 0, the better our network actually works. To adjust our weights, we use this technique called gradient descent. To find the minimum of loss function, we calculate a gradient of this function, and it shows us using small iterating steps. It shows us where we should go to reach the global minimum, to minimize our loss function. To sum up, the learning algorithm has the following stages. First, we start our network with random weights, random parameters. Then we pass our information through the network and receive result in the output. Then we compare it to our prediction and calculate an error. Then using this error, we propagate this error backwards through the whole network to each neuron and adjust them with the help of gradient descent. We continue iterating these steps until we consider that we have a good working network. So, application of neural networks. Neural networks are used in business to predict, for instance, cost of stocks. It can be used in robotics to recognize objects and obstacles in front of robots and manipulate in control manipulators. Also, they can be used in healthcare to process medical images, diagnose diseases, and predict the result of different medical methods. And also they can be used in input and processing of information to recognize handwritten text in speech recognition or object recognition on images. And also they can be used in video games. Thank you for your attention.
So now we have the question time. If any one of you has any question, so you can ask. Okay, let's start.
Yes, thank you for your presentation. So my question is, how can I meet neural networks in my everyday life? So where can I meet them? Any examples of them?
You can meet them, for instance, in your phone if you have this application, this popular application that converts photographs in styles of different artists, you know, like Prisma or something like that.
Yeah, please.
Thanks for the presentation. Did you ever build your own neural network?
I have built a really simple neural network that recognized handwritten digits and classified them.
Okay, thanks. Any other questions?
Yes, simple question.
Yeah, sure.
Maybe small philosophical ones, but it's about application of artificial intelligence in the future. Could you imagine a situation where in the future, due to the artificial intelligence, would paves the way to the future unemployment caused by robots, which push out the real human life from the working place and completely substitute them on the offices? So it means unemployment. You see, when you have just a situation, you came to the office, IT company, you see many, currently you can see many guys who are making the program, they're coding guys. But now in the future you'll see robots which do the same, but people like you, like these guys, they completely would be unemployed and have no idea how to.
I think there will be jobs for people who will actually write these networks, who would create these networks.
If you talk about the machine learning, at the next step of maybe technical evolution, the machine will be used to create the new machine and new neural networks, and this process will be more efficient than maybe people can do. So maybe our future as humans for maybe support thus super computers or maybe artificial intelligence, or maybe in do you understand me?
Yes.
So maybe our future will be related with another aspects, far from creation of those tools, because those tools will be more powerful than the human brain.
I think
it was just a comment.
going to be in future.
Actually, yes.
So it's hard to tell.
Okay.
Could you imagine situation in the future when machine will teach human to do something? Now it seems to me human teach machine to do something. Yes. But what about situation when it could be vice versa? Machine will teach students, will teach humans. Is it possible in the future? What do you think about it?
It depends on what are we talking about. For instance, there can be a robot teacher for children in schools that would teach some basic knowledge, like primary school or something like that. Or if we're talking about the things that people don't know but robot does, we're talking about creating artificial intelligence that would be more powerful, actual artificial intelligence. It would be more powerful than our.
It means it's quite possible in primary school robots will teach.
If humanity would invent actual, real artificial intelligence, not like neural networks that are used. If humanity would create actual artificial intelligence, I think yes, it's possible.
Just imagine a funny situation where you're talking this way because I was brought up by the robots in my kindergarten. Okay, yeah, thanks.
Yes, I have the question from also this area, the problem with humanity. Do you happen to know that machine learning and such as neural networks very succeed in learning any board games, and already in 20th century the program DeepMind for the company IBM have won the world champion chess player Garry Kasparov. And nowadays almost each game neural networks won in any board game in a competition with a real brain. Doesn't it make you scary that it feels useless of human brain in future in this field of technology?
Nowadays, neural networks can work in very particular area, but human brain can work in more common areas. So neural networks nowadays are better in really very particular area.
But neural networks can learn itself and to know new knowledges, to achieve new.
It's not like that. They are mastering their particular field where they work. They are not get new knowledges from other sources.
I have read about the method machine learning. It finds information in the net and learns itself.
Yes, it finds information in the net, but it can do other more wide things, like our human brain.
Thank you for your presentation. What are the similar biological neurons in human brain to mass neurons from computer science?
As I said, the artificial neurons are based on work of biological neurons. Biological neurons has inputs, and they're called dendrites, like artificial neuron. It has a part that converts information in form of electrical pulses in case of biological neuron, and in form of digits in artificial neuron. Then it decides whether it is going to be activated or not, and then pass this information through the output.
Like biological?
Yes, like biological.
I read the article about how many neurons are in human brain. It's about 100.
Hundreds of billions, I think.
What?
Hundreds of billions.
Yes, but how many neurons in computer science are now?
It depends on what task you want your network to perform. It can be few neurons, or it can be lots of neurons. It depends.
Maximum. What maximum now?
Maximum. I'm not sure. I think it depends on your resources of your computer. So, yes.
I want to speak about the problem when computer neurons will be more than biological neurons. It will the problem when machine will be more clever than man.
As I said, it does not depend on how many neurons in network, in artificial network or in biological network. It depends. Our humanity haven't invented such network that can perform different tasks. They are trained to perform particular tasks, and we are not talking about becoming more clever than human nowadays.
So yeah, and I want to add to this question I see you, and I want to add something to this question, like can computers be smarter than people? It depends on how do you understand the word smart? What do you mean by saying smart? So yes, computers count way better than humans do, so way faster, like you can't even imagine such speed, but they can do this. And talking about chess games again, they are counting the consequences. Chess game is not just about creativity, it's about the memory. Exactly, the memory of combinations of your steps. So that's why computers play these games better. But if you compare, for example, tasks of creating a picture of something, so research show that it's difficult for machines to learn the thing called art. So they can produce some pictures, yes, they can, definitely, but they can't apply the style of human. They create their own machinery pictures. So that's the question. What do you mean by saying smart?
About creative.
About being creative.
Yeah.
So that's a really difficult question because they are not supposed to be creative. We don't know what creativity itself is. It's like the way to find new solutions, or it's just a way of, I don't know, improving your own skills. We don't know what it is actually. So I don't think, no, well, it's my personal opinion, but I don't think that computers will just reduce any human work. It's just impossible. They are not able to find new ways. They are trained specifically. They are just math functions. So that's the point. They can, as Alexei said, they can do specific work. Count really fast, well, choose the combination of steps, yes, they can do it. But actually create something new in the way of absolutely new way. I'm not sure that it's possible for them.
Maybe for now, just
Maybe for now, we don't know. We don't know what will happen in 50 or 100 years.
I heard about one theorem about from math logic. It is Gödel incompleteness theorem, and it says that so it's about mathematics.
Maybe you mean more low or no?
No.
Okay, I think that you will search a little bit, and after our speakers finish their speeches, we can discuss it more deeply. Yes, your question.
What do you think about thank you for your presentation? I have such a question. What do you think about existence of such profession as software engineer? If artificial intelligence will able to create any website, any application program by myself?
As I said, as we discussed it already, I think that there would be profession that would create these new networks or support working them, like data analytics.
Changing the ways of our lives. Like we won't need the people who build websites, but we'll need people who build networks that build websites. And we're just choosing another ways of professions. So the same as on the factories, when the labor work is changed into the robotic mechanisms, like robotic arms and other things. So these people are retired, but they can find a new job, another one. So that's the point, that yes, we probably won't need some professions that we need now. But who knows, maybe we'll need enough professions. Thank you. Any other questions? Yeah, please.
Excuse me, a much more light-hearted question, I'm sorry. But you seem to glance over it on the last slide, so I wanted to ask you if there are any really simple examples of using neural networks in games, like really simple, like classic games and stuff like Tetris and stuff. Maybe. Was it used anywhere?
Yes, there's a network that are trained to play old school Atari games. These networks play the game by itself. They learn how to play and they then play.
What about in development?
In development, I think neural networks can be used as simple AI for characters.
All right, thank you. Yeah, thanks. So, any other questions? No? Okay, thank you, Dasha. Thank you very much. Yes, and now we want to introduce our second speaker, Leah. Now it's your turn with your presentation.
Let's start. Welcome. My name is Lev. You can contact me on email lemon.farmel.cc. So before I start, I want you to tell one, probably not a scary story, but I was a little bit scared. Because 3 days before this presentation, I just watched the Instagram and I saw the post of our president who said, "We need more investigation in our IT sphere." And you know, that's bad. Why it's bad? Because every time when you hear the government want to do something with spare, it doesn't mean it's only IT spare, but in the engineering, technical something, military, we do something bad because we want to control everything. And last year, there was one project in our government, which was the number 6688. So what is about? It's about to control our traffic, use the DPI technology, which means deep pocket inspection, which means all the traffic will be controlled by the government. And even the Tor can't do something with it. So it's very cruel, I guess. But fortunately, this project wasn't accepted, and we have free internet right now. So what is the onion? How you can see, there is a few vegetables on the picture. There's onion and garlic. So why this name is called like this? It's a bit later, but at first I will tell you about the history of this technology, because I guess to understand the complex of the system, you have to know the background about this. So probably we have to start right now. So routing history. The Office of Naval Research is a military organization in the USA, which in this started developing the first network for military, and the main feature of this, it was security. And at the start we don't think about anonymity at all, because it was only for military purposes. And in 1996, the first published first development, the proof of concept, was made on the solar systems, which contains 5 nodes. And it works. It was very fine, because why not? And the main idea of the first generation was to create more nodes, to specify the security and make it more complex, more connection, and everything works fine too. But one thing, it was all made on Data Helmet protocol. Anyone knows about it? No, it doesn't matter. But it doesn't matter, because it had one vulnerability, and it was very bad for that, and they just overwritten everything. Not everything, but most. And in 1998, the first nodes, one was provided for Canadian Ministry of Defense, and it works very fine, and everything was great. In 2000, end of the 0th generation, it's like we made these 5 nodes and we don't need it at all. We have first generation, we have working nodes, we have almost 100,000 of connection per month. But it was very massive network, and the military was we are doing great. In 2002, it was the end of first generation, because a lot of things were even published in 1996, but not applied before the second generation. And the interesting thing, it's like a motivation or something like that, but the second generation was written by the student of Cambridge University, like a project of his graduated year. So contribute to the Tor, and like free internet, great again. And 2004 development of the second generation, we have almost 100 nodes around 3 continents. And in 2003, they published the Onion networks as under MIT license. It means it is open software, and you can commit, publish, take the code, modify like you want it. So it's free to public. And yes, the main idea is the hidden wiki. I guess it's the start of Tor era, because when you first time at the Tor and we don't know what to do, first thing you have to do, go to the hidden wiki. And you can see, what can I do here? What can I just download or not download, where can I talk with someone, forums, and other things. By now, it's almost 6,000 nodes around all the world. But the greatest thing is you can, by yourself, come to home and just go to thetorproject.org and see how can I build my own node relay. And you can contribute to the Tor project. And the special thing which all of us love is if your Tor relay will work 2 months, you will the community will give you a cool T-shirt. Everyone loves T-shirts, so just contribute to the Tor. So how Onion works? So we will see the Tor network because it's the most popular and everyone can use it. So we have the 3 layers. The first layer is the relay encryption. So everything starts from there, and then our information is encrypted at first. After that, the path of the nodes are built. And the middle relay is just a transfer protocol to other nodes, but it's just to make your traffic be more hidden. Just nobody knows where it comes. Nobody but you knows where traffic will go, but everything, an exit relay is just for the last node. From there, the exit node is a global network. So, for example, if you reach some sites and it wants to leak your IP address, it will only know about the last node. That was the exit node. And nobody knows from there you come, and this is so long road. So yeah, Tor very likely without so much to use it. So yes, additional security. That's probably most interesting part in the presentation because you have to know the special things which will save your private info and other stuff. Very great. So Tor browser, it's development of Tor project. So to use, it's most popular and powerful tool, and it's based on the Mozilla Firefox, and you can use it everywhere, like Windows, Linux, MacOS, it doesn't matter. And we have over Tor security. It just OBFS 3 and 4. Which makes your traffic more complex, it's more security algorithms and other stuff. VPN, just virtual private networks, SOCs, and proxies. So, and yeah, we have like on the screen, we can see built-in bridges. It's like I said before, you can start a relay, you can use the bridges. It's almost one thing, but it helps you to, for example, in my house, my provider don't able me to use Tor. I don't know why, so I forced to use the bridges. And yes, you can see Make Azure works in China. China's government said we don't like Tor at all, we just block all IPs and you can pass it. But this thing is helpful. So use it if you're in China and want to use Tor. Well, that's my favorite topic about JavaScript. JavaScript is a cool thing, cool technology. A lot of animations, checks, and other stuff are very cool, but you have to know one thing, 99% of trackers are written by JavaScript. So, if you don't want to be unsecure, you have to turn off the JavaScript. At all. Fortunately, in Tor browser we have a pre-installed add-on which calls NoScript, which allows you to configure your pages to how you want to see the JavaScript on the pages. You can even disable it all. So, and yes, don't talk a lot. The main maybe rule, if you on the deep net, on the dark web, you don't have to tell your real info. You don't even tell some nicknames, don't leave the emails which are using ClearNet, because you can be easily identified by if you have associative emails or something like that. If you are a fan of some group and you use the nickname and someone knows, you can be unsecure. Yes, it sounds stupid, but I will tell a bit later about the story about one guy who was caught by police. Well, happens. Yeah, I want to tell about the Unix. It's one powerful desktop operation system, which was based on Debian, heavily modified it. And the main idea is all the traffic is come from which traffic you want to send. It's under torrent. And it's not very popular because probably tails are more popular. I don't know. It's probably Assange or something like that. Say it use tails because it's very safe. And everyone say, okay, we will use tails. But it's very cool because the authors said our OS are so cool, so even if you have a malware on your computer, it will not leak your DNS. So it's impossible to see users' real IP address. So why nobody using it? I don't know, because probably no one needs this. And personally, I just use it for 1.5 hours because I just wanted to know how it works. And just, okay, I have no task, delete. So, and yes, one thing is what garlic, if you remember this picture. Here it is. Oops. This one, okay. So, why it calls garlic? Because it's more complex, and it's like a just pieces of this garlic are just create into one huge piece. Because it's like the Tor, it's peer-to-peer system, and I2P has one like it's very slightly similar, but we have difference. So Tor able to go to the global network, so you can even use Tor hiding services, and all the sites are besides. And I2P is just complex system with the fence, and your traffic can't out of the bounds of this fence. And the main idea is even if you have two computers, it's already have the I2P system. So that's very cool, but it's very more complex because a lot of encryption are used. At least 5 algorithms are used. How you can see on this diagram, just very cool and very strange because we are just very enthusiastic and secure. So one more time about anonymity. The probably most not popular, but some guys know about the Silk Road. It's just a black market when you can do very bad things, just sell weapons, sell drugs, sell people. All you want to do is just download some malwares, botnets, many things which are not allowed in the real life, in the real markets. But this guy was caught by FBI because he used his nickname on the ClearNet a long time ago. He just used for a blockchain or something like that, and after that he used this nickname on his own market. And then we know about this, we just track him and catch him in the library. He just sent it to the library. Well, I will tell about it because public access points are very dangerous because you came here, you used the Wi-Fi, and then you go, and no one knows about you nothing, just because a lot of people come and it's impossible to track you. And don't use old nicknames or emails, it's very dangerous for you. And yes, no one can provide 100% anonymity, because even the guys who build the Unix, actually I can't trust them with 100%, because I guess we have some backdoors or something to know about his very system. So beware of this.
Okay, thanks, yeah. I want to begin the question. Okay, I'll do the first one, if you're not against. So, clear. From my personal experience, I've used Tor multiple times, but I wasn't satisfied with its speed. What's wrong with it? Why is it so slow? And is it possible to make it work faster? Because you're waiting for like 5 minutes before it sets up. Is it okay?
No, just it's okay because a lot of because for first it's encrypted. A lot of nodes are built. It's long road. So sometimes you will have a good road. It will be much faster. But every time when I use Tor, my first Tor experience was probably in 2013 or something like that, and that was really slow, but probably last year when I used it, it was way more faster. So it's not very slow. And it's fortunate, but because the road always random, so even if you try a new identity, it's a new road, so probably you're not lucky.
Sounds sad. Thank you for your answer. Yes, please.
Thank you for your presentation. My question is, so you told us about the Tor as a main tool for anonymity in internet, yeah? But as I know, it's just the most popular. And is there any other ones that probably are better but not so popular as Tor?
As I said before, yeah, we have I2P. I2P is a network, but as I said before, there is a difference. You can't access to the global network with I2P. You can only access your own resources, because it can be even not connected to the internet at all. You can just plug LAN cable to one computer to two, and you can create the I2P system. So I know about it calls Java Anonymous Proximizer, has some of that, but it's not even complex like Tor. So it's just like proxies or VPN. Yeah.
My question is staying aside of the technical question about connectivity speed. It's more about, I have never heard about this hidden wiki before actually. During the presentation I also on this paper about this. It's actually a bad idea, yes, to use hidden wiki, because it's hidden wiki is a collection of illegal sites.
No, not at all. I will say one thing, because
when finish is a collection of illegal sites which you can where you can buy drugs and things like that. No?
Okay, I will tell one.
When I saw your slide with from US, I mean particular site or seized by special committee in US.
You know, that was only for the black market.
Is illegal to use this stuff? I mean, hidden wiki is illegal?
No, it's not illegal, because it's just a library with books, and you can find something. You know, Hitler's book Mein Kampf, is it illegal? For example.
Maybe in particular country, yes.
It's like that, because the main idea of this, because we are free in internet. It's not this. Yes, I don't like the black markets at all, because it's very bad for our society, you know. But it's like, if you know about this, does it make harm for you or something? It's just the resources when you can go or not go. If you have a purpose to buy something, you will find another road to buy something. I don't think hide-and-seek makes some bad for you.
I also heard some opinion, if you're trying to search for a particular hidden wiki site, you definitely, like the others, will be included in a particular database of particular service. It means because you're trying to find something, maybe it's illegal. No. So it's about being free in the internet. Yes. It's about just to be free in the internet.
For example, if you don't like censorship or you don't like some copyrights, you can find a huge base of books, for example, or music, and you can use it and download. But beware, because a lot of malwares are here. Because everyone wants
to using something without copyright is illegal.
A bit.
Maybe not a question, some short information. Thank you for your wide analysis of maybe different tools available for ordinary users. But I think it's necessary to add one additional tool, the Brave browser. Do you know what is it? With a line on the logo. It looks like this one, and it allows to prevent the tracking of your maybe search requests and so on. It's a very powerful browser. It seems it's free and open source, but I'm not sure. But please check it because it's really interesting tool.
Thank you.
Yeah, thank you. Any other questions? No? Okay, thanks, Leo. Thanks again. And now it's time for our last speakers.
It's not a flash drive, it's another part from the laser pointer. So you can copy a presentation and then it's necessary to use it.
Guys, one question. Anyone needs a break? So we can have like 5 minutes break here, for example. Yeah, have a nice video, thanks.
А что сказать по-российски? Может, это F сказать.
Второй бинарный файл увидишь?
И порешил.
Точно так же. Тут надо фускировать, да? Нам надо
Я только что ставил. Ну там нет чарта.
Вот так порыв, и смотришь. Решай, да?
из logical artificial intelligence. Ты не пошел. Которого Video recording.
So you guys, please take your seats. We're continuing with our last presentation.
Hello everybody. My name is Mohamed Aziz. I am from Mauritania. I don't know if you know this country. It's in the northwest of Africa. Today I'm glad to present you a topic about penetration testing in Wi-Fi network.
Maybe you need to switch on.
After a brief introduction, I will talk about different algorithms and protocols in Wi-Fi security and about their flaws. And before your questions, I will make a brief conclusion. Wi-Fi is a technology for radio wireless area networking. It's a trademark of Wi-Fi Alliance. And before Wi-Fi, we had the wired local area network LAN, which is kind of physically secure. You can't penetrate to this. You can't penetrate to this network without being connected by cable. So we need we will take volunteer privacy for this new technology Wi-Fi. This one uses for encryption for RC4. When you look at this RC4, it's a concatenation between a short initial vector, only 24 bits, and the keyless identification. The encryption is simply exalt between this RC4 and the plain text. So this is a weak encryption. It can be cracked simply if we have enough data. Now let's test this. We need two laptops. One of them is a simple client, or maybe not laptop, maybe smartphone or any client. One of them is the attacker using Linux, which is a special operating systems for penetration testing. We will use AirPack NG utilities. It's not for she's not related to topic. The process is like here. Firstly, we need to monitor our air with the network, the wireless adapter using the NG. Next, we list the Wi-Fi's in our air. After that, we choose one of them encrypted with web and begin sniffing packets by this NG. Sniff these packets in special files pick up. So now if the network is not enough active, we can use a particular utility or PNG to stimulate the network by spoofing ARP request to the client. So now we are ready to fire up our main utility, AirPack NG. This utility will analyze the file pickup, take packets, analyze the packets in this file, and analyze this to deduce the decay. This will take several using our built-in network adapter. This can take up to an hour. If we are using a wireless adapter, external, it can be done in a few minutes. So when enough data is analyzed, our character engine will show us static like this. Note that these screenshots are not mine. I took them from now let's turn to the Wi-Fi protected access, which is now widely used, especially the WPA2. WPA was intended to work in the same wireless adapters forward with upgrading frameworks. WPA2 was deployed after that with new hardware. WPA2 uses more secure encryption, ISCCMP. And both of them have two types of authentication, and an alternate type, which is WPS. The WPA personal or pre-short key is authentication means for handshakes. The enterprise is intended for the enterprise. It uses a third part server for certification. Now let's see the flaws. For pre-short key, this authentication can be cracked by dictionaries if the password is not enough strong. So this depends. The success of this attack depends on whether the password exists in this dictionary we are using or not. For the new enterprise, it can be compromised with fake certificates. And if we are enabling the WPS, Wi-Fi protected setup, so we have a well-known weak point, which is the WPS pin recovery. We'll talk about this in this example. So the process is like this. First, of course, we begin monitoring the area by Roman entry. After that, we list the Wi-Fi's to take one of WPA to see the WPA encrypted networks. And then we use the command wash to see if the WPS pin is enabled. So if the WPS pin is enabled, so we are in this case. And we can use the utility river to crack this pin. Will take, if we are not using external adapter, can take about 9 hours, 10 hours, because it's a brute force. If we look at the pin, it's like here, it's 8 digits. One of them is the checksum. The others are divided in 2 blocks. So the access point can confirm the access point confirms the validity of each block separately. So this reduces a lot the time to do this. For example, the first block will take 10,000 operation. If one operation takes, for example, 3 seconds, so all of this can be checked in 10 hours by internal adapter. So here are a screenshot. Here we are using Thermal engine. This is the interfaces. This 0 is already created to monitor the command wash. This is the access points with WPS enabled. So now we have only one access point with WPS enabled. Use this PSS ID or MAC address to fire up trigger. The node will take time, wait, and finally we get the pin. Now, some theory about WPA3. It was announced the last year. It replaces the pre-shared cable by a new technology, simultaneous authentication of equals. This provides protection against brute force, which was a big problem of pre-shared cable. And also, this WPA3 provides privacy on public network, which was a really problem because connected now in the public area. Your data is concluding, we can say that web is not at all secure. For the pre-shared key is secure if we use strong passwords. You have up to 63 characters. So it's enough secure if we use a strong password. And if also we don't have great limits. WPA2 enterprise can be compromised only with means of special hardware like So, thank you for listening.
Guys, do you have any questions for the topic? Yeah, please.
Okay. Thank you for your presentation. So you told us about the third version of VPA, and you told us that it was announced, but it is released. So is somebody using it now, or only VPA 2?
Yes, it is announced, and they began producing new. It needs new hardware to implement this. And they are already implemented, but it is right now it is very foolish use, and we don't know a lot about this.
Thank you. Any other questions? Yes.
Thanks for the presentation. Did you ever hear about the rodeo access points? It's a technology which when you build your own access points to sniff traffic and to make the same SSID, and because of the Wi-Fi interface, when it's closer and most powerful connections, devices are connected to the rodeo access points. And does it? Did you ever hear about it? And what you can tell about it?
No, I think I didn't get it. Didn't get the.
Well, okay.
Maybe you will comment on it yourself.
Oh yes, of course. So the main idea of this is like we have the second router, for example, which has the same ID as the original. And if it's close to us, we will connect on this router, not the original. And we will snitch the traffic. Well, and about the penetration, because have a few algorithms which can identify the rogue access points.
So it's kind of spoofing.
Yes.
I didn't read about this. Of course, there are a lot other types of attacks. I only mentioned a few.
Like the most popular ones, right?
Well, yes.
Yeah, so thank you very much. Any other questions?
Yes, I have. So, thank you for the presentation. Have you ever cracked the VPA test protocol? Have you ever cracked the VPA1 protocol? Yes, yes.
Question of question. No, I didn't crack it.
Thank you.
Yeah, any other questions? No? Okay, then thank you, Aziz, once again. You can take a seat. So for today, that's it. Thank you very much for coming. Yes, I hope you enjoyed it. And thanks again for the speakers, because today the speeches were really, really interesting and really diverse. And I want to tell anyone that if you want to become a speaker for the next time, you can just contact me, like say it right now, or contact me on Telegram to become the speaker for the next time. And we'll be all happy to see you once again. So thank you all for coming. And for today, that's it. Have a good day, have a good evening, and just continue to improve your skills. Thank you very much.
Thank you.